wildlife monitoring, military applications, and noise pollution mapping would be very good for this. Also, as a team, we wanted a mission that would bring a commercial product. So this mostly left us with military applications and noise pollution mapping. Eventually, we didn't choose for military applications due to ethical reasons. And we went on with noise pollution mapping. So, noise pollution, much like normal pollution that's bad for your lungs, noise pollution is quite bad for your ears. So, government agencies like municipalities and other bodies are very interested in this, in areas like highly dense urban areas and nature reserves where it needs to be quiet. So they pick up this noise by looking, by attaching microphones on the top of buildings and seeing where this noise comes from. Normally, this is not done with aircraft because aircrafts produce a very turbulent, chaotic noise that is very hard to filter out using computers. But when we looked at what a design would look like, very flush, when we incorporated only plasma actuators and no moving control surface into our design, we saw that we might be able to develop a commercial product to fulfill this mission. So that's what we set out to do, and that's what we designed the aircraft to do. So of course, an aircraft is most silent when it is gliding and its propeller is turned off. So we took a lot of inspirations from existing glider aircraft and made it with a very high aspect ratio of about 12. As you can see, the wingspan is 3 meters. We could have made this higher, so the aspect ratio would be even higher. But if it's above 3 meters, you would fall under a different class. And with that class comes more regulations like another design that we incorporated that improves the aerodynamic efficiency and hopefully the noise it produces is a passively foldable propeller. Basically, when we turn off a motor and go gliding, the wind pushes the propeller back, giving it a more aerodynamic. Let's see the mission profile we created. So the green area here is the area that we want to noise map. We start by entering the area at an altitude of 120 meters, at which we turn off our propeller and glide back down over the course of a kilometer to 55 meters altitude. At this point, we turn back on our propeller and glide back up to 120 meters, only to repeat the process again to the other side. So we repeat this after the entire area is covered and we fulfilled our mission. So we talked a lot about noise, and we also wanted to make sure that our aircraft does not produce a lot of noise at ground level. So we did an acoustic analysis and found that ground level are at 22 decibels. This is much like leaves rustling in the wind, and is thus very silent. To monitor nature reserves. And to monitor nature, you also need to preserve it, of course. So we took this into account when designing and made our aircraft recyclable, but also looking into the places where our materials come from. So we really wanted to have locally manufactured and producible materials. So that's why we made our structural system out of aluminium, which can be found in Eastern Europe, specifically the Balkan, and poplar wood, which is a tree native to Central and Eastern Europe. There is a small part that couldn't be acquired in Europe. This is balsa wood. You might know it from lightweight aircraft. You can find this in both Ecuador and in northwestern Africa. Another way we incorporated sustainability is, of course, we made our plane electric and not using any sort of other type. And we made our plane modular. So modularity, of course, comes with a trade-off that you increase your weight and increase your points of failure, but it comes with the advantage of producing less waste. As you can see, we divided our system up into the fuselage, 2 wings, 2 booms, and an empennage that can be bolted back together. So in case we break our left wing beyond repair, we just have to replace the left wing instead of the entire aircraft, which tremendously will reduce the waste that we produce in the end. So in this entire 10 weeks, we did a lot of designing for structures, aerodynamics, propulsion, and the electrical system. But in this presentation, we really wanted to focus on the innovative parts of our design and the future-proof parts. So continuing with that topic, I want to hand the mic over to Simon, who is going to talk about the integration of plasma into our actual system.